Hello, hi everyone. This is Tushar. I welcome you all to Biotecnika. Today in this session, we'll be going through some chemistry questions, the questions that came in NEET 2022. So join in as fast as you can so that you can enhance your knowledge with this session. So before this session, we have already completed 3 sessions which were related to chemistry. We have also completed 4 sessions related to biology. In that, we have discussed in detail the explanation of each and every question that will help you to revise, that will help you to gain knowledge, particularly if you are preparing for the next exam in 2023. And to all those till now, you might have checked your answer sheets, you might have known which answers are correct, which answers are wrong, so you might be knowing your score. So congrats to all those who have cleared or those who are thinking that they have achieved mark greater than what is required. And for all who have not able to make the cutoff, don't loosen your heart. We have this year, you can try your best, and today the sessions that we are doing will help you to solve these questions. You know the detailed explanation of all the questions that came in NEET 2022, and this will definitely help you in the next coming exam. So we'll wait for a couple of minutes and then we can begin the session. So let's get started. So this is the first question. Which one of the following is not formed when acetone reacts with 2-pentanone in the presence of dilute NaOH followed by heating? So this is the first question that I'll be discussing. Which one of the following is not formed when acetone reacts with 2-pentanone? Acetone reacts with 2-pentanone in the presence of dilute NaOH followed by heating. Now, the important thing is, do you realize what is the reaction it is involved? The reaction between an acetone and 2-pentanone in the presence of dilute NaOH. It's an example of aldol condensation. So by seeing the conditions, by seeing the reactant, you should be able to know that which reaction we are talking about. So this is a question from aldol condensation. Now you can have two approaches, where one way you go through the options and then decide for the answer. We will take the straightforward route, the formal route that needs to be done with the questions. So let's understand how it is done. So we have acetone. In the question, they have given acetone. This is the structure of acetone. And in the question, we have 2-pentanone. 1, 2, 3, 4, 5. 2-pentanone. We have this. Just check. 2-pentanone is given to us and acetone is given to us. So we have acetone. This is the structure of acetone, and this will be reacting with 2-pentanone. 1, 2, 3, 4, 5. 2-pentanone will be there. So in the presence of base, aldol reaction will take place. Now you know there are two types. The same molecules can involve in self-condensation, or they can do cross condensation. So we need to see all the possible conditions, we need to see all the possible products. So the easiest way is to look for the carbanion, where the carbanion is forming. So first let's see which all places the carbanion can be formed. The carbanion can be formed here, the carbanion can be formed here, the carbanion can also be formed here, the carbanion can also be formed here. So let's take different cases and see how many products we can get. Okay, so just let me change the color. So if the carbanion, the carbanion is forming here, so this carbanion will attack here, this carbanion will attack here, OH will be formed. So in this case, this carbanion will be attacking here. 1, 2, 3. 1, 2, 3. So this is the thing we'll be getting. Now condensation, due to the condensation, we'll be getting this product where this H and this OH will leave, and we will be getting a alpha beta unsaturated alkene. So this is what we'll be getting. 1, 2, 3. 1, 2, 3. So this is one of the product that we are getting. So the essence is you need to find the carbanion where it is getting formed and then attack the carbonyl center, and in between those two center you have to make the double bond. Is this clear? So first we need to generate the carbanion. We'll see all the possible carbanions where it is getting formed in this particular reaction, and then attack at the other carbonyl center and then just make a double bond through it. So this is one product you can get. Okay, this is the one product we can get. What is the other product that we can get? If we start with this carbon ion, the same thing, since it's a symmetrical molecule, the same molecule will be getting. So this two carbon ions, this is the product that we will getting. If we take this carbon ion, if due to the presence of base, if this proton is abstracted, this carbon ion will be formed. So if this carbon ion will be formed, and if this attacks, what we can see, if this is attacking, so the product that will get, this group is attacking over here, so it will be OH and two methyl groups are here. So just let me rewrite this structure. So what we have this. Now this group is attacking this. This is what we have. Now, as I have already said, this proton in the presence, since it is alpha to the carbonyl group, is more labile, so it can easily go. So this H will go, this water. So water is basically released and double bond is formed. So from this we'll be forming this compound. 1, 2, 3. So this compound, if this carbon ion is getting formed. So if we have the similar with the trick, you can now do it. Similar thing can be formed. Now we can just write the relation, 2 pentanon structure, 1, 2, 3, 4, 5, and just form a double bond, because since this center is reacting, it will attack the carbonyl center. So we can directly write a double bond here. Now you know the mechanism, how it is following. So this. So one product is this. So and if these molecules, one of the molecule is getting self-condensed, if getting self-condensation is taking place, so what can we give? Let's say if this molecule and this molecule are combining together, if these two molecules are combining together in the base, so we can find this molecule. If a base is here, it will attack. I'll just rewrite it. So basically, if we go through all the options, and analyze properly, we'll find this. You can see, now I'm saying the trick. Now we have seen the detailed process. Now we can use the trick. So if you cut this bond, you can just add water area and see here, carbonyl is there. Here the base would be there. So this is the substrate. This is the acetone moiety that we have here. So if you have seen the previous all the substrate, then we can see that this is not forming. So this is not forming when acetone is combining with 2 pentanon. Why? Because you can see here, if you break this double bond, so let's say you will be having this moiety. So I'll just replace it. If you are breaking this double bond, so since it's beside the carbonyl center, so carbon ion must be here, and the carbonyl will be here. So if we are breaking this, so basically we'll get something. We'll be getting something, this one compound and the other compound, for the other compound this will be carbon, and for the other compound this will be carbon ion. So a H will be associated with it. Okay, so we can see that this substrate is not 2 pentanon. Rather, you can count 1, 2, 3. It is 3 pentanon. So this product cannot be formed. So which one of the following is not formed when acetone reacts with 2 pentanon? So the option is C. So the correct option is C. Option C cannot be formed. So let's move to the next question. So the next question is, if the radius of second Bohr orbit of the helium ion is 105.8 picometer, what is the radius of the third orbit of lithium 2+ ion? So it is asking us the radius of the third orbit of lithium plus ion. Now the important thing to note here is this information about the helium, they have just given you the confusion. So you need to take care, you need to be very simplified in a thought process when you are going to an exam. So you need to focus what are the facts that are necessary for you to understand to solve this question. So this is the extra information they have given. It is of no use to us. So what we need? We need to know the radius of the lithium plus 2. We need to the radius of the lithium plus 2 third orbit. So what do we know? We know this relation. What relation? Rn, the radius of the nth orbit, is 52.9 into n square upon z in picometer. N square upon z in picometer. Now, when you are remembering this formula, you need to see which unit is associated with it. It is important because this same formula can be written as 0.529 n square z upon z into Armstrong. So this will be in Armstrong unit. This will be Armstrong unit. So the formula that we'll be using here is 52.9 n square upon z picometer. Now, what is a picometer? So just to give you an information, 1 picometer is equal to 10 to the power minus 12 meter. So this is the relation. And for 1 Armstrong, it is 10 to the power minus 10 meter. Okay. So this is the just two important facts that will help you in solving many more questions in the coming exams. So we need to use this equation. So what are the facts that are given us? See what is given us. They have said to find the lithium plus 2. Now for the Bohr orbit, we know that these formulas are only valid for atoms for which are equivalent to hydrogen, or I can put in this way, the atoms where only one electron is present. So for those only this Bohr orbital thing is possible. So in lithium plus 2, there is only one electron, so we can use this safely. Now for lithium, Z is 3. For lithium, Z is 3. Atomic number Z is 3. And what is the orbit they are saying? They are saying the orbit to be 3. So just plugging the values and solve it. So if we plug in the values, what do we have? N is equal to 52.9 into, what is the N? Since it's the third orbit, the N will be 3. So it is 3 square upon Z. What is the Z here? So for lithium, it is 3. Atomic number is 3. So it is 3. It will be in picometer. Now, if we cancel this out, it will be 52.9 into 3 picometer. Now, if you solve it, you will get it to be 158.7. 158.7. If you solve it, you will be getting 158.7. Whenever you are solving this question, focus on the unit. That is important. Focus on the unit. So the correct option is 158.7 picometer. Okay, so let's move to the next question. Now the next question is saying a 10-liter flask contains 64 grams of oxygen at 27 degrees C. Now assuming O2 gas is behaving ideally, the pressure inside the flask. So they are asking that if a particular gas is put inside a box, if put inside a container, and what is the pressure exerted by that gas. So what are the facts that is given to us? So whenever you are solving a physical question, see what are the facts or what are the data that is given to you and how you can extract the information from this data. So that should be your thought of approach. So what do we want? We want pressure. And for ideal gas, what do we know? For ideal gas, we know PV is equal to nRT. This is the equation for ideal gas that we know. PV is equal to nRT. Now, see, what do we want to find? We want to find the pressure. The question is asking about the pressure. So just rewrite the equation in terms of pressure. So pressure will be given nRT upon V. So pressure will be given as nRT upon V. So what are the values that we need here? They have given us volume. The volume is given to us as 10 liters. The volume is given to us 10 liters. And they are saying the temperature to be 27 degrees Celsius. Now, this is also an important thing that you might miss sometimes when you are calculating temperature. Always remember to convert it to Kelvin. So that's how we solve the question. So these are very small things, but when you are solving this, you might miss them. So you need to be very careful. Okay. So how do we convert it into Kelvin? Just add 273 to it. So if we add 273 to it, it will be 300. It will be 300 Kelvin. So the temperature that they are saying is 300 Kelvin. Okay. Now what do we need? We have volume here. We have temperature here. The R is a constant, which is universal gas constant. And they have also given us the value. So what is the factor that only left? It is N, number of moles. So they have given us the grams of oxygen that is present inside. So how can we find it? Number of moles is equal to mass given by the molar mass. So for oxygen, gas, it is 32. So it will be 2 moles. So it will be 2 moles. So basically N, the number of moles of gas involved is 2. So just the next thing is plug in this value in this equation and solve it. So I'll just do it. So pressure is equal to, in place of number of moles, it will be 2 into R. So we know what? We knew here P equal to nRT upon V. This is the equation that we want to plug in the values and solve for P. So P is equal to number of moles is equal to 2. And they have given us the gas constant to be 0.0831 liter bar Kelvin inverse mole inverse into temperature is 300 Kelvin divided by volume. They have given us 10 liters. So it's an important thing that when you are solving this physical question, one more thing that you need to write, you write the equations, or I mean to say the units along with the numbers that you're writing. So that will help you in two ways. It will help you to keep a check on the unit, final unit, and it will also help you that if you see that you want to find a value for mass, and if you are getting liter, that means you might have done some error. So two ways it will be helping you. So write the units when you are solving this. So from liter, this liter will cancel. From Kelvin, this Kelvin will cancel. This is mole. So this mole will cancel. Now just the values are there. 2 into 0.0831 into 300 upon 10 upon 10. Now if you solve this exactly, it will come close to 4.9. It will come close to 4.9. So the correct answer is B. The correct answer is 4.9. What is 4.9? 4.9 bar. So the correct answer is 4.9 bar. So let's move to the next question. So the next question is from electrochemistry. So they are asking based on the Nernst equation. So find the EMF of the cell in which the following reaction takes place at 298 Kelvin. So they have given us a reaction. They have given us a reaction where nickel solid is getting converted to nickel 2 plus, and it is getting basically oxidized, and simultaneously Ag plus is getting reduced to the Ag solid. They have given us the E naught for it, and they have also given the value of 2.303 RT upon F to be 0.059. So our task, our job is to find the EMF of the cell, the E cell. Our job is to find. So before we move into this question, I want to just specify one thing, that this value NTA might have done some error in printing it. If we solve with this value that it is given here, 10.5, you won't get any answer which is matching from the option. Only way to get is if you take the value of the E naught cell to be 0.5 volt. The only way, if you are able to solve and get the answer from the desired option that they have given us. I would like to stress this point, that they might have done it, or some printing error is there. So if you take it to be 1.05 volt, then we can solve this question exactly. So let's consider it this value and solve this question. The E naught cell to be 1.05 volt. Okay, so let's start doing it. Now we know from the Nernst equation E cell, E cell is equal to E naught cell minus 2.303 RT upon NF into log Q. So 2.303 RT upon NF into log Q. Now what is the Q value here? It is the reaction quotient. So what is the reaction quotient that we have here? So the reaction quotient is, Q value is basically concentration of nickel 2 plus divided by, since what we have seen, what is the reaction that we are seeing? In this reaction, nickel was getting converted to nickel 2 plus, and 2 electrons would have been released, and simultaneously Ag plus was gaining 2 electrons, and it was forming Ag solid. So you can see the number of electrons transferred. So the number of electrons transferred in this process is 2. Number of electrons transferred in this process is 2. And the Q value, the Q will be concentration of, since this nickel is solid and we don't consider the solid, concentration of solid to be unity. So we'll be having here nickel 2 plus, concentration of nickel 2 plus upon concentration of Ag plus square. Since we need to multiply the stoichiometry, square. We need to basically do its square. So it will be this. So just E, we can just rewrite it. E cell is equal to E naught cell minus 2.303 RT upon F. This value they have given to be 0.059, and we know the number of electrons transferred is to be 2, and this is log concentration of nickel 2 plus upon concentration of Ag plus square. So this is what we are getting till now. So this value is 1 point, considering I have said that considering this value to be 1.05, this to be 0.059 upon 2 log Ni2 plus and Ag2 plus. Just from the above relation, just from the question, we need to plug in these values. Just from the question, these values are given. We just need to plug in these values and solve it. So just let's plug in the values and just solve it. So what we have here, so E cell is equal to 1.05 minus 0.0. See, they have given here the value of this value they have given us 2.303 RT. So it is 0.059 upon 2 into log, I have already mentioned. So what is the concentration for nickel? It's 0.001 upon concentration of Ag square 0.001 square. So if you solve it, it will be 1.05 minus 0.059 upon 2, and it will be basically 1 upon 0.001. 1 upon 0.001. So it is basically, if we solve this, this will be 3. Since it is getting reversed, 0.001 will be 1 upon 1000. Will be 1 upon 1000. So this 1000 will go up. So log 1000 will be 3. So basically from here we'll be getting 3. So basically here we'll be getting 3. So I'll just rewrite the relation here. E cell is equal to 1.05 minus 0.059 upon 2 into 3 into 3. Now if you exactly solve this relation, you'll get the answer to be D, 0.9615 volt. You will getting 0.9615 volt. Okay, so considering, I'll again say it, considering that this E naught cell to be 1.05 volt. 1.05 volt, will be getting the answer to be 0.9615 volt. Okay, so let's move to the next question. This reaction, for the above reaction, they have given us a reaction where oxygen is converting into ozone and they are in equilibrium. For the above reaction at 298 Kelvin, they have said that Kc, the equilibrium constant, Kc is found to be 3 into 10 to the power minus 59. What is the concentration of oxygen at equilibrium when the concentration of O3 is given? So they have given the concentration of O2. The concentration of O2 at equilibrium, they have given us 0.04 molar, and they're asking the concentration of ozone. So how can we do this question? So we know equilibrium constant. We know is equilibrium constant is equal to multiplication of product of the, say this O3 square will be having this upon the reactant, product upon reactant. So this is what we'll be having from this relationship. The stoichiometry will be to the power of the particular concentration that we are having. Since it's 2 O3 are being produced, so O3 square will be there and 3 O2 are reacting, so we'll be having the cube of the concentration of oxygen. Okay, cube of the concentration of the oxygen. So just we have all the values here. Kc is given to us. The value of Kc is given to us. It's 3 into 10 to the power minus 59. The concentration of oxygen at equilibrium is also given to us. Just plug in these values and solve it. And what do we want to find? We want to find the concentration of O3. So just rearranging the equation, if we rearrange this equation, so concentration of O3 will be Kc into concentration of O2 cube root over. This is what we want to solve it and find the solution. So just solving it, what is Kc? 3 into 10 to the power minus 59 into what is the concentration of O2 that they have given us? It is this 0.04. So I can just write 0.04 as 1 upon 100. I can write this 1 upon 100 4 upon 100, 4 upon 100, 0.04 to be 4 upon 100. So if we cube it, it will be coming 10 to the 64 into 10 to the power minus 6. 64 into 10 to the power minus 6. So if you solve it exactly, you will get it to be 4.38 into 10 to the power minus 32. If you solve this value, the answer that we'll be getting is 4.38 into 10 to the power minus 32. So the correct option is option B. So the important thing was to write the relation for the equilibrium constant. Okay. So let's move to the next question. So the next question is from solid state chemistry. So it's saying that copper crystallizes in FCC. Now what is this FCC? Face centered. The FCC is face centered unit cell. So copper crystallizes in FCC unit cell with cell edge length they have given us. What is the edge length that they have given us? A. Basically it is 3.608 into 10 to the power minus 8 they have given to us, and the density of copper they have given us, the rho value they have given us 8.92 gram per centimeter cube. They have given us this thing. So they are saying that it's a face centered cubic unit cell. They have said us face centered cubic unit cell. FCC is given to us. We know the edge is given to us, and the density is given to us. They're asking the atomic mass of copper. So how do we do this question? So let's try and solve this out. Now, density of anything is what? Density of anything is mass upon volume. Density of anything is mass upon volume. Now, what is volume for a cube? If we know the edge length to be A for a cube, so the volume will be A cube, A to the power 3. So the volume, if the edge length is A, so the volume will be given as A cube. This is the first thing. So we know the volume now. So the volume is A cube. Now, what is the mass? What is the mass of a unit cell? So what is the mass of a unit cell? So how can we find that? So the mass of a unit cell will be equal to the number of atoms present in that particular unit cell into the mass of each atom. So the number of atoms present in a unit cell is given by Z or rank. The number of atoms present per unit cell is basically rank. So number of atoms present in that unit cell is given by rank, which is Z. And this we need to multiply with the mass of each atom. Now, how do we do that? So we know molecular mass. So what does this molecular mass tells us? It tells us about the mass of 1 mole of that substance. So it's basically molecular mass is the mass of 1 mole of that substance. And we know that this mass contains Avogadro number of atoms. This mass, 1 mole of any substance, contains Avogadro number of atoms, elements, or anything. So if you want to find the mass of each unit, it will be M upon Na. Mass of a single atom, M upon Na. So the mass of a unit cell is Z, which will give the number of atoms present in the unit cell, divide into M upon Na. So this will give us the mass of the unit cell. Now for FCC, face centered cubic unit cell, what is the rank? So for the FCC, we know that constituent elements are present at the edge, and also I'll just change the color. Also at the face, each face they are present. Each face they will be present. So there are 6 faces. And for each phase the contribution is 1 upon 2. So since 6 faces are there, so the total contribution from each phase is 1 upon 2. So we'll be having 3 atoms here. 3 effective number is 3 here. Now from the edges, so we are having 8 edges, and the corners, 8 corners, we are having 8 corners. So the contribution per corner is 1 upon 8, and we are having 8 corners, so it will give us 1. So the rank for this is 4. So the rank for this FCC unit cell is 4. So the mass of a unit cell is equal to Z m upon Na, where we can just substitute what we have got. The rank is 4m upon Na. This we have got till now. So what is the volume? What is the volume that they have given us? The volume that given us, we'll just check it quickly. So the volume that the value I'll just clear up this. The A value is AQ. From here we can solve it. AQ. So it's 3.608 into 10 to the power minus 8 centimeter cube. Minus 8 centimeter cube. And the density of the copper they have given us. So we have just now understood how it is coming. We know rho is equal to Z m, which is the molar mass upon Na. Okay, so let's just plug in the values. The density is given to be 8.92 gram centimeter cube upon centimeter cube. Z is 4. Molar mass we need to find, and we have your Avogadro number 6.023 into 10 to the power minus 23. We have this Avogadro number. Now if we solve this for m, which is 8.92 into 6.023 into 10 to the power minus 23 upon m, so the value will be 4 here. So if we solve this exactly, so it is 8. The A cube volume is also there. So what is this? I'll just rewrite this. So density is Z m upon Na. This is the mass that we have, and we need to divide it by the volume. We need to divide with the volume that we are having. So Zm, just plug in the values. Z is 4. M we want to find. Avogadro number is 6.023 into 10 to the power 23 into volume. It is divided. So it will be, what is the volume from here? We can get 3.608 into 10 to the power minus 8 centimeter cube. Just we need to cube this. So rho, and the rho value, the density value is already given to us. It is 8.92. Now if we exactly solve this for m will be 8.92 into 6.023 into 10 to the power 23 into 3.608 into 10 to the power minus 8 cube upon 4. We'll get the value to be 63.1 U. So if we solve this exact calculation, it is 63.1 U. So it's an easy question if you know the formula, but just the process, the numerical is tedious. You just need to focus and calculate correctly. You need to multiply correctly since many values are included here. Otherwise, it's a very easy question to do. So the correct answer is 63.1. So let's move to the next question. The next question is compound X on reaction with O3, which is basically, as soon as you read somewhere O3 is involved and you see here ZnH2O, so you can just easily identify the reaction. It is ozonolysis. Now in the presence of zinc synthesis it is done, it is reductive ozonolysis basically. So compound X on reaction with O3 followed by zinc H2O gives formaldehyde and 2-methyl propanol as products. So what basically we are looking into, we are seeing ozonolysis reaction. We are basically seeing ozonolysis reaction. So I'll just take an example before we move to this question so that it is more clear how we can easily solve this question. So if we have a alkene like this, where it is CH3, H, and this is CH3, and O3 is added to it. O3 will react first to form a ozonoid. So this is the structure of a ozonoid. HCH3. And then in the presence of zinc and water, this will be cleaved. This entire complex will decompose to give us the product, which one will be forming acetone, where this group was attached, plus will be forming the aldehyde here. We'll be forming the aldehyde here. So what is the moral of the story that we are seeing? That whenever this alkene, so basically in ozonolysis reaction, this alkene is oxidized into ketone or aldehyde. So in particular alkenes, it is oxidized to ketone or aldehyde. So you should be able to break. So the trick is to break this double bond, break the double bond and attach oxygen to other sides and form the respective carbonyl compounds. So that's how we can solve it. Okay. So let's see what is given in the option. So they have given us formaldehyde. So they have given us formaldehyde. This is the structure of the formaldehyde, and they have given us 2-methyl propanol. 1, 2, 1, 2, 3, 2-methyl propanol. So they have given us 2-methyl propanol. Now we can just proceed through the reverse way. We can connect them through the carbonyl groups and see what it is forming. Just I'll write this so that we can connect and see it. This is the two reactants that we have. They have given us. So one is formaldehyde and the other is 2-methyl propanol. 1, 2, 2-methyl propanol. So when you are combining this, when you can, this is basically we are doing reverse. We are analyzing in the retrospection. We are doing it. So this alkene would have given us the product. This alkene would have given us the product. This alkene would have given us the product. This alkene, if we are doing ozonolysis, it will give us formaldehyde and 2-methyl propanol. So let's see what is the, also they are asking us the nomenclature for it. So how can we do here? So we can start from here. We can start numbering from the alkene side. So 1, 2, 3, 4. So we'll be getting 4 means but, 1 position in is there, butene, and at you can see at 3 position, the methyl group is attached. So the product that we'll be getting, so the product that we will be getting is 3-methyl but 1-ene. 3-methyl but 1-ene. So the correct option is option 2. So the correct option is option 2. Option 2, B. 3-methyl but 1-ene is the correct option. So let's move to the next question. So the next question is, the pollution due to oxides of sulfur gets enhanced due to the presence of. So this question came directly from the NCERT, from environmental chemistry chapter. So exactly, if you go through in inorganic, particularly inorganic and environmental thing, if you go through NCERT, you get direct questions from the NCERT. So this question was directly taken from it. So it is saying that the pollution due to oxides of sulfur get enhanced due to the presence. So what are the oxides of sulfur basically? The oxides of sulfur are sulfur dioxide and sulfur dioxide. Now in the presence of what all things, this sulfur dioxide is enhancing, this sulfur dioxide reaction to form SO3 is enhanced. This is what it is asking. In the presence of which the components from here, this reaction where SO2 is converting to SO3 is enhanced. So I'll just show from NCERT, we know that sulfur dioxide in the presence of particulate matters, they are forming more sulfur trioxide. It is given exactly, and we know, and also in the presence of ozone, O3, also in the presence of ozone, the conversion of SO2 to SO3 is more. The conversion you can see in this reaction where SO2 is combining with SO3 to form sulfur dioxide and giving oxygen. And also in the presence of H2O2, hydrogen peroxide, this sulfur dioxide is reacting to form sulfuric acid. So if we see closely options, if we see and analyze the options closely, we'll see that what the question asking, pollution due to oxides of sulfur get enhanced due to the presence of which all things? Yes, we have just now seen that the particulate matters increases, acts like a catalyst to enhance the reaction. So yes, it is getting involved. Yes, ozone is also getting involved. We have seen just the reaction where sulfur dioxide was reacting with ozone to form sulfur trioxide and oxygen. But hydrocarbons are not involved. Hydrocarbons does not enhance the pollution, oxides of sulfur enhancement, they are not doing. So the correct option is, so we need A, B and D. So basically A, B and D are involved. So the correct option is C, where A, B and D are involved. So correct option is C, A, B and D are involved. So let's move to the next question. So in this question is from chemical kinetics. From chemical kinetics, we have got this question. So for the first order reaction, what is they are saying? For the first order reaction, A to B, product is forming, A is forming to product, and the initial concentration of A is given to us. The initial concentration of A is given to us to be 0.1 molar, and they're saying that it is becoming 0.001 molar after 5 minutes. It is becoming 0.001 molar after 5 minutes. They're asking the rate constant of the reaction. So they have given us at time t equal to 0, the concentration of this to be 0.1 molar, concentration of this to be 0.1 molar, 0.1 molar, and it will be 0 at time t. Since the reaction has not started, the concentration of the product will be 0 at time t. They have given us 5 minutes. At time 5 minutes, time 5 minutes, the concentration is getting changed to 0.001 molar. This is concentration of A is getting converted to this. Now they have said that this is a first order reaction. So what do we know for a first order reaction? If you remember correctly, the first order reaction KT is equal to 2.303. I'll just rewrite it. KT is equal to 2.303 log A naught, which is basically the initial concentration, upon AT. What is AT? AT is the final concentration or concentration of the substrate at time t. So we want to find K. So we can just rearrange the equation. It is 2.303 upon T log A naught upon AT. So we know the values it is given to us. So what are the values it is given to us? So A naught is given to be 0.1 molar, and AT at time t, concentration at time t, is given to us 0.001 molar. So just substitute the values, just plug in the values in this equation and solve it. If we do it, it is 2.303 upon time is given us to be 5 minutes, log it is 0.1. So 0.1 I can write as 1 upon 10, and it is 0.001. This I can write 1 upon 1000. So I'll just erase this part. And solve this out. So what do we have here? 2.303 upon 5. So if we change this, if we just rewrite this, what we'll get? If we just rewrite this, so we'll getting log 1000 upon 10. So this 10 will be cut. So we are basically getting log 100. Now what's the value of log 100? Log 100 is 2. So basically from this we'll be getting 2. So what we have got so far? We have got K is equal to 2.303 upon 5 into 2. This is what we have got. And if you solve it exactly, the value will come close to 0.9212. The value will be close to 0. So the value that you will be getting will be 0.9212. So this is how you solve this question. So the important thing was to remember the relation, first order relation, which is KT is equal to 2.303 log A naught upon AT. This is the relation. So if you solve it, the correct option is option C. Sorry, option D is the correct option. Okay. So thank you everyone for being with me till this session. So today we have completed this series where we were discussing the NEET this year questions, NEET 2022 questions. I'm sure that this session or the entire series will give you knowledge that will help you to prepare more in better way for the next year. Those who have already secured a good mark, or those who are saying that they are getting a good mark, congratulations to them. And for the other students, it is important for them to learn from their mistakes and learn and solve more questions. You need to sit and solve these questions. This series that we have done will give you the approach that needs to be taken to solve the questions of NEET. So in a way, you will getting the information, total information. And if you want more such content, subscribe to the Telegram group of Biotecnika. Here we'll be teaching properly the concepts related to chemistry and biology. What are the integrities that needs to be taken care of? Thank you, everyone. Thank you all.